wanted to give you guys a very basic introduction to soils. Some of you may have taken more advanced classes on soils. We have a whole soils program here at Cal Poly. So you'll know that this is a very, very, very basic overview of what soils are and how they're created and how they function. So we define soils as the mineral and organic material that supports plant growth on the Earth's surface. And this is usually composed of a mixture of rocks, organic material, living matter, air, and water. In order for soil to actually help support life, there are a number of factors that we have to consider. This includes oxygen. There needs to be adequate oxygen for root growth. Root growth is one of the key factors in growing plants. If you've ever grown a plant and killed a plant, you'll know that the death of the plant often comes from the roots. Soil is also very important in absorbing heat and regulating temperature. It also helps with the loss of heat in the atmosphere. If you have an opportunity, when it starts to get warm here, I want you to go walk in an area where there's very little vegetation, and then go walk in an area where there's a lot of vegetation. You can immediately tell the temperature difference. You can even tell the temperature difference if you just walk on cement and then go walk on the grass. The grass is significantly cooler because a lot of the heat from the sun is being absorbed by the soil and the plants, whereas on the cement, it's just radiating back into the atmosphere, making you hotter. This is also part of why we get what's called city heat effects, because there's so much cement in cities that they just radiate it back out into the atmosphere, whereas in more rural areas, you don't have this heat effect. Another important part of supporting life is water, both water on the surface as well, and especially water in the soils. Carbon is also another very important part. We do a lot of carbon sequestration in soils. There's two places we often sink carbon. One is into the oceans, and we're rapidly realizing that our oceans are becoming saturated. On the other hand, the carbon that's been stored in soils has been released into the atmosphere. So the soils become a way that we can store carbon. Another really important resource in helping support life is the nutrients that we find in soils. There's 16 different nutrients that plants need, and 13 of them come from soils. So soils are made by taking large material, breaking it down into smaller material, and then adding in organic materials. All soils originate from rocks, and we call this the parent material. These rocks can either be on the surface and broken down, or oftentimes they're deeper in the earth and they're broken down as they move up towards the surface. You would have read about this in Montgomery's book on dirt in the chapter that talks about the effects of earthworms on creating soils, particularly the part that studied Darwin's study on earthworms and how that relates to soils. Weathering is also another very important way. Water is a very, very powerful tool in creating soils because it penetrates cracks in rocks. It helps erode them down. When water freezes, it can split rocks. Water also can be the source of friction to have rocks rubbing and breaking down other rocks. So if you have a thing like a river or a glacier or landslides or avalanches, all of which are often related to water, you see them wearing against each other, breaking themselves down and becoming rocks. Chemicals can also mix in water to further break down rocks. These aren't necessarily industrial pollutants. These are naturally occurring chemicals that can add to this process, including acids. And then, of course, plants add organic material to soils, which attract microorganisms, which help create better soils. So when we think in terms of soils, we are often thinking in terms of these different layers of soils. We often think of the O layer as the organic layer. This is the layer at the very surface where we see the leaves and the plants, the dead animals, partially decayed organic materials. This is where humus is formed. It's when you pick up dirt and you smell that earthy feel, that earthy scent in soil, that's this layer, this organic layer. Then we have topsoil. Once again, topsoil is also composed of rich organic materials and minerals. There's also lots of humus here. Then we have the B horizon. This is the subsoil. This is poor in humus, but it's often rich in concentrations of clays and minerals. Clay is a very important component of soils because it doesn't break apart and it's good for retaining water. Then we talk about the C horizon. These are the rock fragments in the soil that are starting to be broken down. There tends to be no plant or animal materials down here. And then we have the D horizon, which is bedrock. And this is the unweathered rock layers. That's the base of the soil layer. And as those horizon bedrocks move up towards the surface, they're broken down into smaller and smaller bits that eventually get mixed with organic materials and become the O and A horizons. So we just talked about parent material as a very important thing that we're using. Climate is also another important factor. So variations in climate can have a significant effect on soils and soil development. Warmer climates tend to have a lot more water, so they tend to have more dynamic weather, so they also tend to break down more. If you have areas that have hot and cold periods, especially freezing, where in the warmer periods that water has the ability to melt and get into rocks, and then you freeze, that can break those rocks apart. Also, variations in topography can play an important role. When you have steep hills, your materials tend to run downhill because this crazy little thing called gravity. And so that impacts how you can develop soils. And then of course, plant and animal life. Like we saw, that O layer, that O horizon layer is developed, has a lot of plant and animal materials. So if you're in a place that does not have a lot of plant and animal life, you're not going to have a lot of soils. Deserts are a good example of this. There's not a ton of plant and animal life compared to other places. So we see these areas just being sand, not soils. And then of course, time. Some people think of soils as a renewable resource, but we really shouldn't think of it that way, because the amount of time it takes for soils to renew can be a very, very long time in order to still maintain really good, rich O and A horizon soils. So there's components of soil. So about 45% of all soils is minerals. These are the partially decomposed rocks, sand, silt, and clay. Then we have about 5% of soils that are organic materials. These are the partially decomposed plant and animal matter. About 25% soil is air, which people don't usually think about, but all those spaces between that material is filled with air, and another 25% of that is filled with water. So those, what we think of empty spaces, are not empty at all. They have air and water in them. When we think about the physical properties of soil, this is part of that 45% we just talked about. We usually consider gravel, sand, silt, and clay as the components of soil. Sand and silt are merely broken down rock fragments, often consisting of quartz, feldspar, mica, and other materials. Chemically, they're pretty inert as compared to clay and organic material, which are actually responsible for most of the chemical reactions that occur in soil. We use these four components to come up with the different descriptions we have of soils. And if you ever take a soils class, you'll find out there is a ton of different types of soils, but that is beyond the scope of this lecture. So then we also have water in soils. Like I said, about 25% of soils is water. We usually talk about infiltration, percolation, and permeability. So infiltration is the process of water soaking into the soil. Percolation is the movement of soil downward, even deeper into the soil. And how permeable the soil is the quality of the soil that allows for both infiltration and percolation. If it can have infiltration and percolation, we say that it is permeable. And you can see in this image, if there's too much or too little water, we have wilting. So the plants are not getting the right amount of soil, right amount of water. And yes, plants are pretty picky with the amount of water. Too much water, too little water, you get yellow leaves. So if you're ever growing a potted plant and the leaves start to turn yellow, you need to ask yourself, is this too much water or too little water? Oftentimes it's too much water. And so you end up with what we call saturation. So organic matter is very important, and there's a lot of ways that organic matter occurs in soils. We can talk in terms of earthworms, insects, bacteria, fungus, and other organisms. I encourage you to go get a handful of dirt sometime, get a good handful of soil and look at how much life is in there. You can smell the life. We know that the richer the life in the soil, the better the soil is. So when we do things like spray insecticides, fungicides, and other pest controls on our plants, that permeates into the soil and can have a significant effect on the life in the soil as well. So things like earthworms and insects, they actually help create openings and tunnels in the soil. They also, like earthworms, eat little rocks and they poop out dirt. It's called casings. It's really awesome. You want earthworms. Fungus and bacteria also help break down matter and nutrients. We get carbon sequestration in soils through the breaking down of the decaying roots by these funguses and bacteria. And the farther that down goes, the more stable that sequestration is. So plants play a huge role in the creation of soil. They do a couple things. First, they anchor it. One of the things that you're reading about in your text, and you'll learn when you study the Mayan civilization, that when you cut down all the plants, you create erosion of your soil because the soil is no longer anchored. This is a huge problem when we talk about clearing forests for agriculture. We're seeing this happen. We saw this happen all over the Midwest. It's what partially led to the Dust Bowl. This is what we're seeing happen in the Amazon. So this clearing of this root base in order to engage in agriculture can have a real problem because those roots are anchoring the soil. Plants also use water that is in the soil. So that's when you water your plant, it absorbs the water. That helps. We just talked about the water cycle. There's also air in the soil, and a lot of oxygen is absorbed by plants through their roots. We often think of plants absorbing oxygen through just their leaves, but they also absorb it through their roots. Like I said before, there are 16 essential nutrients that plants need. 13 of them are obtained from soils. And of course, I noted that root hairs absorb the nutrients that are dissolved in soil. Root hairs are also what decays that allows for some of those nutrients to remain in the soil. So there's a number of uses for soil in agriculture. Cropland is one of the key ways that we use soils, but we have to be very conscientious of how we engage in cropland agriculture. We've become much more aware of how fragile our soils are over the last 100 years. We started to really learn that with the Dust Bowl, and then we kind of forgot for a bit, and now we're starting to remember maybe we shouldn't be doing as much tilling and overturning that soil as we're losing large quantities of soil. We also use grasslands for grazing lands. Forests are a huge, important part of agriculture. And then, of course, it helps clean our water structures. And agriculture depends upon soil to grow all the food, fiber, and plants that we have. It's what we use to survive. So caring for our soil is very important. I hope this has given you a little bit of an introduction to what soil is and why it's important. And I hope you have a great day.